right, picking up with number 11, it says solve each equation. Please box your final answer. Be sure to check your solution. So the first thing to note is that when you're solving rational ratio comparison functions or equations, you want to remember that there's a lot of different ways to do these. So if the way I show you right now is not the way that you prefer to go, but you know how to get to the right answer, then great, go that way. There's a lot of different ways to approach this. Kind of depends on who you had for your algebra teacher a few years ago. So the first thing I like to do is figure out what is my least common denominator. Well, the first term has a denominator of x minus 4. The second one has a denominator of x plus 5. This one I'm going to factor into x plus 5 and x minus 4. And so what I notice is that this one has both of the terms over here. So this becomes my least common denominator. Had it not had those two terms in it, I might have had to do a little bit more work to think about what my LCD would be. And you can go back to, I believe it's back in Unit 8B, to look at how to find a least common denominator. From here then, that means that right away we know x can't be 4 and x can't be negative 5. Okay, so in this next step, again, a lot of ways to do this. I like to view this as, okay, x minus 4 needs an x plus 5 to get the common denominator, which means that up here, I also need an x plus 5. This one has x plus 5. It needs an x minus 4, which means I need an x minus 4 up here. This one already has everything, so this needs nothing. I mean, you could multiply by 1 over 1, but unnecessary. So x times x plus 5 becomes x squared plus 5x over x plus 5, x minus 4, minus, when I distribute this 4x, that's supposed to be in blue, 4x, come on, 4x minus 16, I'm going to keep that in parentheses, and the reason I keep that in parentheses is that I will need things to distribute. Oh, that's a minus 16, I said it, I didn't write it, 4x minus 16. All over, now I have the common denominator, x plus 5, x minus 4. All of that is then equal to 36 over x plus 5, x minus 4, because that one didn't need any changes. So now, because each one of my terms has a common denominator, I get to look at this numerator line as one big equation that needs to be solved. So this will be minus 4x plus 16 is equal to 36, because I just distribute that negative. X squared plus x, 16 minus 36 is going to be negative 20 equals 0. This then, when I factor, I'm going to get x plus 5 and x minus 4 is equal to 0, which means x equals negative 5 and x equals 4. But I'm supposed to go back and check my answers, and you might remember from the very beginning, I said x can't be equal to 4, so that one's not going to work, and x can't be equal to negative 5, so that's not going to work, in which case this equation has no real solution. Actually, that's just no solution. Doesn't matter if it's real or imaginary. No solution. There's no x value in the whole world that would make, oh, come on, that would make this sentence a true math sentence. Okay, this thing will never be true. All right, solve the equation. Oh wait, I forgot number 12. Sorry, number 12 is way down here. Solve for x to the 2/3 plus 11x to the 1/3 minus 3. Some students view this as, okay, well, 1/3 means the cubed root and 2/3 means the cubed root squared. That's a good way to think about this. So this is 4 cubed root of x squared plus 11 cubed root of x's minus 3 is equal to 0. Well, what I'm noticing is I have this term squared and then a constant. So this is a good candidate to be a u substitution. U is equal to the cubed root of x. So what that does for me is it says 4 u squared plus 11 u minus 3 is equal to 0, and this now becomes just a quadratic that I need to solve. So I'm going to factor by splitting the middle. So I'm looking for things that multiply to negative 12 and add to 11. That's going to be 12u minus 1u, and then I still have minus 3 and 4u squared. Splitting the middle, remember, is just a way to factor so that you can then break up into groups. This will be 4u, u plus 3, minus 1, u plus 3, which means I get 4u minus 1 and u plus 3, which means that u is equal to 1/4 and u is equal to negative 3. And if I was solving for u, I would be in good shape. But I need to remember that I originally stated u was actually subbing in for the cubed root of x. And again, u was really subbing in for the cubed root of x. So if I want to actually solve for x, which is what the original question asked me to do, how do I undo a cubed root? I need to cube both sides. So x is going to be equal to 1 over 64, because 4 cubed is 64. And x is going to be equal to negative 3 cubed, which will end up being negative 27. And I do believe both of those work when you go back and sub in. All right, solve the equation. Please put a box around your final answer and be sure to check your solutions. This one, avoid the temptation to just subtract 8, divide by 27, and take a cubed root, because this is a sum of perfect cubes, which means I'm looking for 3 answers. I want to identify that A is 3x and B is 2. So what I'm really using is SOAP. I'm going to have A, same sign, B, A squared, opposite sign, AB, always positive sign, B squared. So if you need a little reminder, this is the formula that I'm using. This now is then equal to 0, which means that I'm going to set 3x plus 2 equal to 0. Maybe 3x plus 2 equal to 0, which means that x is equal to negative 2/3. And I'm going to set 9x squared minus 6x plus 4 equal to 0. And I know these are going to be 2 imaginary roots. So I'm just going to jump right into the quadratic formula. X equals opposite b plus or minus square root b squared minus 4ac divided by 2a. X is equal to 6 plus or minus 36 minus 4 times 9 is 36 times 4. Grabbing a calculator because I can't do mental math. Yes, I can do mental math, but I'm choosing not to. It's going to be negative 108 all over 18. Feels like I could do something to simplify that, and I can. For sure, the I can come out. See if I can get my pen to work. Thank you guys for your patience. So x equals 6 plus or minus the square root of 108 can break down into 3 and 36. So I'm going to have I times 6 root 3 over 18. Each one of these has a 6 in it. So x is equal to 1 plus or minus I square root of 3 over 3. Okay, final answers. Right is a complex number, a plus bi. Put a box around your final answer. So remember, we have I, negative 1, negative I, 1. And that's when you have I squared, I to the third, I to the fourth. When we have a division with i's, we want to multiply by the conjugate of the denominator. We've started using conjugates and limits too. What you do to the bottom, you got to do to the top. So across the top, I'm going to have 14 plus 8i minus 21i minus 12i squared all over 49 plus 28i minus 28i minus 16i squared. So let's clean things up. Across the top, I'm going to have 14 minus 8 minus 21 is negative 13i. Negative 12i squared is really negative 12 times negative 1. Over, those are going to cancel. 49 minus, come on. Okay. Struggling with technology today. 49 minus 16 times I squared, which is negative 1. That becomes 14 minus 13i plus 12 over 49 plus 16. 14 and 12 makes 26 minus 13i all over 65. It says that we're supposed to write in a plus bi form. So I'm going to have 26 over 65 minus 13i over 65. And I would say you could leave that as your final answer. You also could simplify your fractions. 26 divided by 65 ends up being 2/5. And 13i over 65 is minus 1/5 I. Okay, so that'll be your best final answer. This one is okay, just not simplified with fractions. Last one for this video, we have negative 6i to the 11th plus 9 square root of negative 16 plus 15. So I think these ones it's best to just go term by term. So I'm going to start with this negative 6i to the 11th. And the way you want to think about I to the 11th is you can do 11 divided by 4 in your calculator. 11 divided by 4 is 2.75, which means you've got 2 and 3/4, which means that this is really the same thing as I to the 3rd. Okay. Another way you can think about it is I to the 11th is equal to I to the 4th times I to the 4th times I to the 3rd. And these are each just 1 times I to the 3rd. Overall then, I to the 3rd is the same thing as negative I, which means this really is 6i. The next term then, 9 square root of negative 16 is 9 times 4i, which is 36i. And then 15 is, well, just 15. So, final answer in real plus imaginary form is 15 plus 42i. All right, I'll do number 15 in one last video.